Today we are doing geometric series, which is chapter 12.2. Your learning target for today is I can recognize if a series is geometric, and I can use the formulas to evaluate for missing information. So we're doing similar to yesterday's lesson, but we're talking about series versus sequences today. So a geometric series is the sum of the terms of a geometric sequence. So for example, we have a geometric sequence below, and now we are going to find the sum of this example. In order to find the sum, we need these two equations. Now there isn't a correct or one versus the other, it's just a personal preference. The sum of a finite geometric sequence is this Sn equals either our first term minus our first term times our rate to the nth power all over 1 minus r. That is right here. Or we have our sum equals our first term times 1 minus the rate ratio to the nth power all over 1 minus the ratio. So in both of these equations, our A1 is our first term. The R is our ratio, or our multiplier. The N is the number of terms in our sequence, or in this case, series. So on this example up here, we could use one of these two equations to solve for the sum of that sequence. Now we're going to jump to this example. It wants us to find the sum of the first 8 terms of 14 minus 70 plus 350 minus 1,750 plus, and it's going to continue on. So what we need to do is we need to find our first term, which is 14, our ratio, which we're going to take that concept, we're going to take our 70 and we're going to divide it by 14. I apologize, a negative 70, and we're going to divide it by 14, which is going to give us negative 5. So our R is negative 5. Now we already know this is a geometric sequence, so we don't need to check that that's a common ratio. It is going to be. And now our N, this specific problem wants the sum of the first 8 terms, making our N 8. So now I'm going to use our Sn equals A1 times 1 minus R to the nth all over 1 minus R. This is going to give me 14 times 1 minus, now be careful, our ratio is negative 5, so we're going to put parentheses all over that, and this is going to be over 1 minus negative 5. Now you're going to notice two things. On the denominator here, we're subtracting a negative, so we can make that adding. But in our numerator, we cannot do that because we're taking negative 5th to the 8th power. So this is actually going to become 14 times 1 minus 390,625 all over 6. Now when you plug that into your calculator, you're going to get a negative 911,456. And that is the sum of the first 8 terms of this sequence. So we're going to continue on, and this problem wants us to find the sum of the first 6 terms. So that tells us our N is 6. Our first term, we can look at this sequence and see it's 16. In order to find our ratio, we're going to take 4, divide that by 16, and that's going to give us 1/4. Now I'm going to use the same sum equation. And I'm just going to plug in my values. So I know 16 is my first term. I have 1 minus my ratio, which you can put as a decimal or a fraction. It does not matter. All over 1 minus 0.25. This will simplify to 16 times 1 minus 0.00024441 all over 0.75, which is going to give you 21.3. So the biggest thing with this section is just knowing this formula, the sum formula, being able to identify your n, your first term, and your ratio, and then plugging all these numbers in. Now we have a word problem. This says Nora earns $50,000 in her first year working. Each year she gets a 4% raise. How much money does Nora make in her first 10 years of working? So anytime we have a word problem, we should underline important pieces of information. 50,000, a 4% raise. How much money does she make in the first 10 years? So I'm going to write down the information I know. I know she starts with, so the first term that I have is 50,000. I know it's asking me about after 10 years, so that means my n, or my last term in my sequence, is going to be 10. Now be really careful. With your ratio, we need to convert 4% to a decimal. So if we are going to change this, 4% becomes 0.04. Now the ratio isn't 0.04 because you need to include what she made the year before. So our ratio is actually 1.04 because it includes this year plus her raise. Okay, so be really careful with that. Now I'm going to use my sum equation. 50,000 is where she starts. 1 minus the ratio for 10 years, all over 1 minus my ratio. This is going to give me 50,000 times negative 0.4802, all over negative 0.04. And finally, I have $600,305.00 is how much money Nora will have made in her first 10 years. So that is all for today. Your homework is page 771, number 14, 37 through 40, and 43. This is also attached as a PDF on Schoology for you to complete.